Hi, everyone. The topic of my presentation is Apache Ignite Adventure Time. I'm going to talk about our adventures when we deployed Ignite into production and when we used. Let me first say a few words about myself. My name is Kamashev Ruslan and I am a software developer for the Tinkoff Bank. I work in the processing department of the bank. A few words about our work. We make transaction processing. In addition, we are the product system of the bank. It means that all banking products other than deposits are handled by our system. Next, I'm going to talk about big pieces of architecture. First of all, we have API. It's usually REST API, sometimes gRPC. API calls a master system backed by Oracle. And some requests go to Apache Ignite. In addition, we have background job. They listen to a Kafka topic, like topics about transaction. They do some processing by Apache Ignite. It sometimes syncs to the master system into Oracle. Next, why did we choose Apache Ignite? The first point is, Apache Ignite is a distributed cache. We wanted to find a distributed system which is able to partition data. The next point, we were interested in horizontal scaling and fault tolerant. The next point is SQL. It is the opportunity to use standard SQL clients to connect the cluster and do SQL queries. For simple analytic, we wanted to give access to our cluster to testers and analysts. It was needed to reduce developer time spent on testing, for example. The next point, PDS or native persistence, which lets us use Ignite as a real database to store our data on disk. The next point is called Compute Grid. As I said before, we do the processing of transaction. We wanted to do it on server nodes where data is stored. Compute Grid is able to do it. The next point, our cluster is deployed in 2 data centers. Ignite is able to protect us from split brain out of box. Let's discuss our cluster architecture. We have 3 data centers. 2 of them are main, DS, and M1. DC equals volume we have. And in addition, 5 nodes of Zookeeper in them. It's the reason why we have 3 data centers. If one of them fails, Zookeeper is able to make it quorum and protect us from split brain. Also, we have 12 nodes at Ignite, 6 per data center. Our Ignite nodes are divided in groups. We call them zone. Each zone stores full copy of cluster data. We have 4 zones. As a result, our Ignite cluster has 4 copies of data, 2 copies per data center. Let's say a few words about the cluster configuration. Our cluster runs on Apache Ignite 2.7.0, which runs in embedded mode inside the Spring Boot application. The cluster is distributed between 2 data centers. It doesn't mean 2 clusters with replication between them. It's one cluster that spans 2 data centers. As I said, we use zones for a backup. In the slides below you will find links to components that implement zoning. It is implemented using backup filter. Each server node of the cluster is marked by some attribute. It determines how to distribute backups in the cluster. In our case, it's zones. As I said, we have 12 dedicated hardware servers with 190 GB RAM each and 410 GB SSD disks. We use native persistent and Zookeeper Discovery SPI. The latter protects us from split brain. The next slide lists problems we faced with Ignite. The first is cache configuration updating problem. After cache was created, requirements changed. We needed to alter the expiry policy to prolong time that data is kept in cache. We looked into the documentation and understood that we can't change it in runtime. Unfortunately, there was only one way to do this. We had to recreate the cache. We had a few options here. The first approach with data loss is that we destroy the cache and create a new one with the updated configuration. The second approach without data loss is a little bit complex. First, we create a new cache with version suffix. For example, if we have mycache, we create mycache version 2, after that, we migrate data into it. Next we switch our application to use new cache, and after that the old cache should be removed. However, there are some issues. If SQL is used, table names would conflict. But you can solve it if you set table name explicitly via query entity. The root cause of this problem is that by default depend on name of value class. When we don't change the name of the value class and just change the configuration, conflicts occur. Using query entity provides workaround for it. The next point is about conflicts in index name. You may use a query entity to or just drop index. In our case, we just dropped old index. The next point is peer-to-peer class loading quirk. As it turned out, it doesn't work everywhere. When we created a new cache, we broke the whole cluster. The reason for it was class not found exception. We read logs and found a line of code that was root. During cache creation, a client node serialized cache configuration and sent it to all server and client node. They couldn't deserialize it because their class path didn't contain the required classes. We hoped to rely on your class loading, but unfortunately this case wasn't supported. How it can be solved? The simple way is to extend a class path of server nodes. The problem with this solution is that it requires a full cluster restart. I don't recommend specifying classes in cache configurations in our case. These were key and value type classes. If we remove them, we lose type check, and we will be able to insert data of wrong types into cache. I suppose it isn't a big problem because it simplifies deployment. When we create a new cache, we don't restart a cluster every time. The case when you use topology validator or filter classes is a little bit difficult. If they are required, you must restart whole cluster and add classes to the class path. The next problem is the peculiarity of the entry processor working. We added a new field to an entity. The binary object format lets us do it. We don't face any limitations initially. We tried to deploy this code into production and caught no method exception. After our investigation, we found out that entity classes on server and client nodes aren't the same. It means that client has the new version of the entity with new methods and fields, but servers don't have any of those. How you can work around it? The first way is to restart the cluster or maybe change deployment mode. Set private or isolate it. Still needs cluster restart. The second way which we ended up using is the way without cluster restart. We use binary object which doesn't need additional serialization or deserialization on server node. We work with binary object directly, thus allowing us to sidestep this issue. The next point is when we were using SQL and we get out of memory. Why does it happen? If we execute queries on large cache that don't fit on heap, out of memory occurs. As I said before, we provided access to testers and analysts to testing cluster. They brought the cluster down from time to time. After a few restart, I was tired of doing it. As a result, I have written some guidelines. Please execute queries on large caches using indexes. It minimizes amount of data stored on heap. They should take a look at query plan before execution and make sure the query will use an index. There's no room for error because the current version of Ignite can't cancel SQL queries. There are some settings that you can tweak here. You can set the lazy mode. Take a look how it is done in Java API and using JDBC driver. Ignite will fetch data lazily page by page. It sometimes solves this problem. As I mentioned before, you should check the query plan before execution, especially when querying production environment. Check the links below. Ignite is not set in stone. Lazy mode is expected to be enabled by default sometime in the future. Perhaps from the version 2.8, the JDBC driver will be able to cancel query. Better yet, memory quota will be added to limit consumption by a single query. My next point is the rebalancing problem. There are two ways of rebalancing data between nodes. First, nodes apply delta updates from WAL. The second way is, node removes data locally and downloads full partition from a remote server node. In the second case, if the node decides that the partition should be truncated and downloaded in full, all delete operations will be written to WAL. This is the problem. Two charts are presented here. The first chart shows free disk space. As you may see, there is a sudden decrease in free disk space on some nodes. These nodes have left topology and returned back. We notice that their free disk space decreased suddenly. The second diagram is the reason. It has happened because the deletions has happened so rapidly. Checkpoints could not catch up with syncing to disk. As a result, number of archive wall segments increased. Wall segments were kept in reserved state because checkpoints could not keep up with writing data to disk. In our case at 4, the problem was solved. We disabled wall for this cache. I don't recommend doing this. If the cluster is down in this mode, we will lose all data in cache. I advise the following. Before a node returns back to a cluster, we must remove cache data and indexes from disk. It will lead to full sync without wall extra modification, but this process may take hours. In addition, you may tweak some property. The first property is a threshold that defines what type of algorithm of rebalancing will be used. The second is the disabling wall when the rebalancing is underway. It is important to say that the second solution isn't the one we ended up using. Here WAL is stopped locally on a rebalancing node. If a cluster is down, we lose data only in one node. It is a safer approach. The next, worst point is consistency problem with PDF. When we happen to run diagnostic, we found out that partitions are inconsistent. We found a warning message in logs. I don't know why it is warning message. I suppose it's a dangerous situation. We used control.tool for doing the diagnostic. We found out that the problem in one of the partition. In our case, it was simple to solve. We just stopped node with the broken partition and removed data from it. After that, we returned it back. It started rebalance just fine. We read a lot of documentation. There are links and some conclusions below. When you create a cache, you should consider the feature read from backup, when it is enabled by default. This feature makes your cluster somewhat faster because you are able to read data from both primary and backup nodes. But, if consistency is broken, you will read inconsistent data. The next point is the atomic caches when PDS is used aren't consistent sometimes. It turns out, unfortunately, there are scenarios when the consistency doesn't work, because it's a limitation of the protocol. In 2.7.0 there is a problem with transactional caches too, but it is expected to be solved in 2.8. The next point is about PDS. Again, we sometimes saw PDS corruption. It usually happened when node left. Then we returned it back. And after that a different failure occurred. As a result we had wall corruption. On this slide is the screenshot of the error. Checkpoint corruptions happen sometimes, too. We already know ways to solve this. The first one is when a node is stopped, removed from baseline topology, and returned back. However, I recommend the second one. Connect to a node as I described earlier, remove all cache data, and start it again. without BLT changes. The advantage of this solution is that we avoid extra rebalancing because any baseline topology change triggers rebalance. In this case, we don't have that. The next problem is partisan mapping chain. The PME consists of phases. One of them acquires cluster-wide lock. If a node leaves at this stage, the cluster may freeze. It sometimes happens to us. There is only one solution. It's the full cluster restart. Life goes on. A lot of problems were solved in 2.8. Here is the list of tickets with description of this specific issue, and the link to Russian Telegram channel. The next point is that we decided to update our cluster because minor versions 2.7.5 and 2.7.6 were released which can solve corruption problem. But we were surprised because Apache Ignite doesn't support a rolling update. If you want to update nodes, you must stop all client and server nodes and do update at once. For us, it means shutting down a lot of our services. I suppose there are the following solutions. Run a new cluster near the old and migrate applications to it step by step. Use of thin client could help in some cases. I finished describing problem. This section is about our plans. We are going to update to 2.7.8. This version has a lot of fixes for issues that we face. Also, we will implement some tool to collect PDS backup in our case. It will be simpler because we have zones, and there are 4 copies. We may stop one zone, make a copy of all data, and use this copy in the future. Third, we are going to migrate to the Gridgen Community Edition because fixes get there faster. For example, SQL fixes are already shipped there. This is the link to the Telegram channel. You are welcome to the channel. It can connect you with a very active Russian community. In addition, I want to present my project of Ignite REPL, which is an interactive Ignite console. That's all. Thank you very much for your presentation. You mentioned 3 points of the future plans. I suggest adding the 4th point. You should collect all these cases in leaflets and give them to everyone who will try to use Ignite because 80% of our technical problems are the same as yours. Thank you very much. It will be useful for everybody. But I have another question. At the beginning of the presentation, you talked about your cluster and how it is distributed per 2 data centers because you wanted a fault-tolerant system. Was there any case when it comes in handy? How did it work in that case? Is it a reference architecture for everybody? Did I do the same, or is it purely experimental? Since we have a lot of backup, and we may afford to lose a zone and sometimes 2 zones, and we don't worry about it for some period of time. Yes, I see. But did it happen? Nodes sometimes get broken. For example, tonight one node may go away but we will sleep without worry because we have 3 backup. Okay, but it doesn't require a geo-distributed cluster. A simple backup will do. But as for this architecture, did you have a situation when one half of the cluster was outed, but the others were? Yes, it did. Unfortunately, network problems have occurred sometimes. Did you have to recover manually after that? Or did the cluster recover by itself? Manually. I recommend clearing them before they go back to the topology. Otherwise there you may encounter consistency problems and problems with wall reservation that may trigger a second outage. Please could I ask an extra question? Are these 2 halves equal by side? Yes, they are. I wonder. Maybe my question is wrong. As I'd understood, if a network has been partitioned, a quorum algorithm stopped the smaller part of the cluster. It's split-brain protection. But how does it work with Ignite? In our case, the algorithm is a little bit trickier. It looks at the size and also chooses the part of the cluster where the older node is the coordinator. All nodes have their order of joining the topology. The oldest node is the coordinator. The part which contains the coordinator will live. But what happens when the coordinator dies? A new coordinator will be chosen. Thanks, everybody, who creates tickets when you meet some of these problems. Also tickets about incomplete documentation. It's very important for the community. This is the reason why these problems are fixed so fast. Anybody else? I have a question. What happens during segmentation with the segment of cluster that is not valid? Does it just restart and rejoin topology? It depends on your configuration. Disregard this. I think it is hard-coded. Ignite has failure handlers. If a segmentation event is detected, it is hard-coded so that node is stopped. As I remember, stop or halt failure handler will trigger which kills JVM. But I don't remember clearly. My question is, if I want to return nodes to topology, should I just restart them? I do not recommend doing this, because, as I said, it leads to consistency problem. You can configure this. For example, Ignite runs inside Docker. After some process dies, the container will be brought back. But this is a controversial point in my opinion. We do it manually without auto restart. Do you just perform manual restart? Just restart the process? Yeah. Could you tell me about your load profile? What do you use it for? You said that you were using compute node. I can't tell you any specific numbers. Why do you use them? For transaction processing in some specific product. I'm not ready to talk about particular cases right now. Thank you for your presentation. Q, you said that you made backups. Could you elaborate how? I said that it was in our plan. How we plan to do it is we have 4 zones. We will stop one zone. Does a zone mean a cluster? No. The zone is a part of the cluster which contains a full copy of data. Do you want global or local consistency on node level? I don't understand. Q, you said that you stop the cluster and do a full backup. No, I didn't say that. It's enough to stop only one zone. It gives me a time frame to make a backup. But I want to offer an improvement. You can use the checkpoint. It doesn't change data pages at this moment. It writes data to the checkpoint buffer. You may use this idea to make a custom plugin which would do a backup. But you must perform a backup on time because checkpoints will abort after some set time. Yes, you need to configure the checkpoint buffer correctly. Maybe it's a way to go. Thanks. Ruslan, thank you very much for the presentation. You said that your master system is Oracle. Could you say a few words about synchronization between your grid and Oracle? And how do you check consistency between Oracle and grid? Did you see cases when we call Oracle but data is inconsistent? If we detect inconsistent data, all requests route to Oracle. It is always possible to fall back to Oracle. But how does synchronization work? Do you use Ignite as a cache? How does it work? We have a scheduled process that syncs data from the previous day to Oracle. Is it an async process? Yeah, it is. Q. I want to ask you another question. Why do you use Zookeeper? I see that there are 4 zones. Each has a full copy. You may stop one of them. 1 or 2 may be broken. But what does Zookeeper do? We get split-brain protection by using Zookeeper discovery speed. But Ignite has this logic built in. When we were testing it, it didn't work. But Zookeeper works fine. We did a test with ring topology. The cluster was split into 2 independent live clusters. I see. Thanks. Zookeeper protects us. Is it used instead of standard discovery SDI? Yeah, it is. Do you just stop all nodes in a zone before backup? How can you do that? Yes, we just stop all nodes. But they may be in an inconsistent state. Yes, we understand it. Is it fine for you? Yes. We also have Kafka. We are able to reset its offsets and reprocess data to the cluster. Okay. What if we compare Zookeeper's split-brain protection with the solution based on segmentation resolver, which would mark a valid segment of more than half nodes which actually check the quorum? Yeah. It's possible, but we prefer this solution because it's simpler, available out of box, and it was developed by Ignite developers. This presentation contains some of my corrections and remarks. If this video was useful, subscribe to our channel, share it with colleagues, and make a donation.